So Mike Graham here, who has three hats, as you can see: professor, entrepreneur, and also the director of the new Aquaculture Center at the Moss Landing Marine Lab. Moss Landing Marine Lab is kind of a sister institution. It sits in between Santa Cruz and Monterey. We have a lot of meetings there, and Jim Harvey, who's the director there, is great. And so I've been really excited about this new venture they're doing, and there's so many policy implications. And I think, as you know, and maybe Mike will talk about this, you know, right now in the world, more than 50% of seafood consumed now comes from aquaculture. So that tipping point just happened. So it really is the future, I think, of seafood and sea. As we'll see, that doesn't just mean fish and animals, right? But that actually means vegetables as well. And I think this just has such amazing promise for taking the pressure off of wild systems and all the externalities that come with that, and also allows for a lot of closed loop systems and a lot more maintained ways that I think will be really good for people and the environment. So maybe Mike will contradict some of that or add some more fuel to the fire. We'll see. But really looking forward to hearing this perspective. And let's give him a warm up.
Well, I appreciate being here. Thank you very much. Actually, have had a long day. I'll talk to you a little bit probably about the personnel aspects of today that have made it longer, as it actually relates a lot to the multiple hats I'm wearing. I'm at Moss Landing Marine Labs. I'm a Southern California boy, raised on the beach in LA, and came up here to do my master's degree after I got my bachelor's down in Santa Barbara. So I went to Moss Landing Marine Labs in the 90s, got my master's. Kelp forest ecology. I was the last kelp forest intern out at the aquarium. And I went down to Scripps, got my pedigree through the #1 kelp forest ecologist on the planet, Paul Dayton, who was down there. He's a wonderful fellow if you ever get to meet him. And that's where I did a lot of the kind of early part of my work that kind of set the tone for what I was doing. Came back up to Davis and got my postdoc out there, added a little bit of molecular work to my science, and then took my advisor's job here at Moss Landing. I got it when he retired in 2002. Moved into Marina, own a house out there at CSUMB. I have 7 children, run the soccer league in Marina, have a seaweed farm, executive director of the City, Center for Aquaculture. Just a whole bunch of chaos in my life. Just exploded this morning as I ran down to Santa Barbara to get some seaweed, had to get some abalone and cayucas. Gave a lecture this morning for the Monterey Bay Aquarium Education Office at Moss Landing, and had to attend to some student issues in the afternoon. So it's been a long day, and I delivered 5 pounds of seaweed to Roy's out of Spanish Bay about 15 minutes ago, and got here. So I'm really excited to be here and kind of talk to you about all of this and how it all relates kind of to everything. So I am a professor of marine ecology at Marine Labs. I teach marine ecology, I teach scientific methods, it's a critical thinking class, aquaculture, and then obviously biology of seaweeds, which is what I do. I'm the executive director of the new Center for Aquaculture at Moss Landing Marine Labs, which will soon be the Center for Aquaculture for the entire Cal State University. I'll talk to you a bit about that and kind of why we're doing that. And I'm the president of Sustainable Sea Culture Technologies, which is a 3-year-old company, and it has a partner of mine who does one aspect of it, and then we do the edible seaweeds part called Monterey Bay Seaweeds, and I'll talk to you a little bit more about that. But I really want to just kind of give you some fodder to kind of think about aquaculture and sustainability from my perspective. It might not be yours, but it is mine, and kind of get you to just think about it so that we might be able to open it up for a lot more questions. I can obviously answer more questions in person than I can with the focused topic that I'm going to present to you today. So I'm just going to kind of give you an overview of what we do and what I do, hoping that it will lead to some other discussions. But the topic, and we will come back and see this again, is the global future of aquaculture. And that's kind of a play on the future itself, but also aquaculture across the planet. And will California play a part? Because as you'll see from what I'm talking about, right now it's not playing much of a part. This is how I've viewed the world for the last 20-something years. This is probably one of the most glorious kelp forests on the planet. It's out of Point Loma in San Diego. This is the kelp forest that Darwin saw when he first got to Chile. It's the kelp forest that some of the most important ecologists have been working with for the last 30 or 40 years. As you can see here, it's all about the kelp. You can hardly see any fish. Right? So I'm the kelp guy. The fish guy is where you see a couple of little specks in the middle of that picture. But this is, these are the undersea redwoods, right? And there's a lot to study just for themselves. But luckily for me, my advisor down in Scripps, Paul Dayton, had a concept that he developed in the 70s. His advisor was Bob Payne. Bob Payne is probably one of the more prolific ecologists. He just passed away this year. He is the inventor of the Keystone predation hypothesis, or keystone species. This is that the starfish eats the mussels, and that's what keeps the intertidal glorious, or the sea otter eats the urchins, and that's what keeps the kelp forest functional. Bob Payne is the one who did that. That's a consumption-based. If you want to think about money, it's an organism that is removing direct competitors for the resource, right? And in doing so, it maintains the system. Well, here's this star student goes in Antarctica and is like, I can't explain anything of what I'm seeing based on what you've been telling me, right? This is not a consumption-based system. There's nothing out there eating anything, but the system is being developed more by these gigantic basket sponges that create habitat and energy. So here you're talking about keystone species, and I'm seeing foundation species. Foundation species are biological species that create the habitat and energy around which the community is founded, right? Which is pretty cool, because by just identifying that one species, you know a lot about the community structure. Now, these aren't just habitat forming species, right? They're edible species too, so they're not just providing the habitat for the energy. Corals, redwoods, mangroves, salt marshes, tundra grasses, these are all foundation species. And for those of you who have ever been out in natural science classes, people probably brought you to these because they're easy to understand. And again, you can focus on a particular species. I love this. I got onto this very early in my career. The coolest part for me is this foundation is itself biogenic. It's biological. It has its own population biology. Life history, sexual reproduction, dispersal, recruitment, all these really cool things that you can study that have ramifications to the community because they, again, help to constrain the habitat and energy production. Right? So it's a pretty neat system to build a career around. I can study population biology. That is individuals within the population, mommies and daddies and babies and recruits and all that stuff. I can then move to community dynamics. Urchins eating kelp, abalone and urchins competing with each other, sea otters eating them, birds hanging out in the system. And I can study biogeography and evolution, right? How often do kelps evolve? Where are the new species evolving from? When did kelps get to the southern hemisphere? All these questions are relevant to this idea of understanding this system, which is pretty cool for me because it makes me relevant to a small group of people, but relevant nonetheless. So where did I go? I travel around the planet. These are all photos I've taken. This is Ixenia from kelp forest that we discovered in the Galapagos. This is a colonia down in the Cape Horn. Cape of Good Hope in South Africa. That's a VW bus. You can see that is a massive kelp forest. This is the giant kelp. This is taken just off of Big Sur, and this is probably the cutest little kelp on the planet. It's a little sea palm, and that shot is taken right up here in front of a silmar. Right? Kelps are generally globally distributed, but certain places do really well with them. Right? And now I can't say that I'm cerebrally better than anyone else who studied these forests, and in fact, very few of us have done as well as Darwin did. You think of Darwin as finches and turtles, and if you've read some of his other books, orchids, barnacles, but most people don't realize that some of the first real understanding of kelp forests came from Darwin. Not when he was out at the Galapagos, but when he was on the Beagle and coming around Cape Horn in Chile and coming into Patagonia, and what he's seeing are these kelp forests for the first time. And I'm just going to read it for you. The number of living creatures of all orders whose existence intimately depends on the kelp is wonderful. Right? And he's already got the foundation species concept down in 1839. I can only imagine these great aquatic forests of the southern hemisphere. At this point, he didn't even know that the bigger forests are actually in the northern hemisphere. With the terrestrial ones of the intertropical regions, right? These are tropical rainforests he's talking about. Yet if the latter should be destroyed in any one country, that is the tropical rainforest, I do not believe nearly so many species of animals would perish as under similar circumstances would happen with the kelp. He's already got, he doesn't even dive. He's just looking at it from the surface, and he gets how intimately linked this system is. He goes on to say, amidst the leaves of this plant, we know it's not a plant, we know it's an alga, but 1839, numerous species of fish would live which nowhere else would find food or shelter, habitat or energy, foundation species again. With the destruction of many cormorants, divers, and other fishing birds, the otters, seals, and porpoises would soon perish also. Okay, he's not very politically correct here, but... And lastly, the Fuegian savage, the miserable lord of this miserable land, would redouble his cannibal feast, decrease in numbers, and perhaps cease to exist. Turns out Darwin probably did more damage to the Fuegian savages than their reliance on kelp forests. But what he was indicating was even the human populations are linked to this resource dynamic intimately. I can't tell you that much more than what Darwin said then. We've got 200 years of research going on since then, and that's about my summary statement right there, which is pretty cool, I think. We have spent a lot of time understanding the intricacies of this, but I think it's pretty amazing to be working in a system that is so conspicuously important that you kind of already know you're on the right track as soon as you get into it. So these are really wonderful systems. They create an enormous amount of energy, which ends up on the beaches, as you guys probably know here in Monterey alone. Just go down to the wharf, you'll see it wash up every winter. You head down to the aquarium and it's 10 feet thick. And associated with that are flies called kelp flies because they're specific to the kelp, and beetles and raccoons and kelp dogs, right? You guys let your dog run on the beach, and the first thing they do is they head to the kelp and they roll in it. They pull the dead bird out of it and bring it back to you. The otter systems, the floating kelp in the water, mola mola is one of the most amazing fishes around, and all you have to do is go to a drifting kelp patty and you're going to see them right there. And then the abalone, probably the tastiest critter we have here. Again, not directly eating the kelp, but hanging out in crevices because that's its #1 predator, eating the kelp that drifts by. So you have these really lush kelp forests and these wonderful animals hanging out in the system. And so a lot of what I've done for the last 20 years is science, basic science, underwater, various places around the planet. I was telling you, go anywhere where kelps go. The best places to find kelp, same places you find great red wine, for the exact same reason, the climate. Foggy, cold, Central California, Northern Chile, Australia, New Zealand, and South Africa, the best red wines on the planet, also have the most glorious kelp forests sitting off the coastline. In fact, we actually have a center, the Center for the Study of Arid Zones, down in Chile, where they study simultaneously the dynamics of the kelp and the vineyards and the citrus just off or inshore of the planet. So I'm not making that up. But I'm going to let this one graph kind of summarize my science. This is the food web that I created, right? And what this is showing you, if you're not familiar with the food webs, raw resources come in the bottom. These are all plants, algae, or other seaweeds. Phytoplankton are in here as well. So carbon and nitrogen come in, create biomass, and it gets fed out through a network of consumers. These are the ones that eat the seaweed directly, either floating seaweed, these dotted lines, or directly eating it attached to the plants. Sea cucumbers, they eat the particles. Abalone, they eat those drift. Sea urchins, they either eat the kelp or they eat the drift. Isopods, little pill bug little things that climb up on the kelp and eat them. Herbivorous fishes, zooplankton. As you move up to another level, these are now the predators. Octopus, sea stars, carnivorous mollusks, these are whelks, they kill other animals. Lobsters, crabs, and shrimp, and carnivorous fishes, big sheephead, bat rays, giant black sea bass. At the very top, we have birds, pinnipeds, sharks, and rays. There's about 270 species represented in this. This is a network. This isn't a food chain. It's a food web, right? So what I studied was, how does carbon and nitrogen move through this? Think of it as an economy. You bring in the resource, how do you distribute it? All right? And that's kind of the background for all the rest of the stuff I'm going to talk to you about in terms of aquaculture. All right, so let's shift gears. 30 seconds. 5 minutes on what Mike Grimm did, and kind of left you with one of my favorite graphs that kind of resonates with me as to what I'm really good at. And let's talk about the new aspects of my life. And having a underwater kelp forest ecologist stand in front of you to tell you what sustainability is. I know what sustains me. If you want to take it that way, right? The capacity to endure, as in terms of Webster's, too simple, not meaningful to any of us, and probably just not even worth talking about. Wikipedia, right? Of course, you got to go there. That one got pulled up by my high school boy who said, at least go to Wikipedia. So I went there. The potential for long-term maintenance of well-being, which in turn depends on the well-being of the natural world and responsible use of natural resources. There's a little too much well-being in this definition for me to be useful, but it's kind of getting there, this idea that there's some sense of goodness in the way you utilize resources. Well, I like the last one, which comes from the Dictionary of Sustainable Development. Meeting the needs of the present without compromising the ability of future generations to meet their own needs. That's the definition I personally like. I can still be a carnivore. You can still be a vegan. We can both subsist and be happy in a sustainable life using this definition, as long as both of us are able to continue living our lives without harming the ability of anyone else to live their life the way they want to live it. So that's kind of my vision of sustainability. And we can discuss it later if you guys want. But at least it's simple enough for me that it allows me a target to aim towards enhanced sustainability. When something is less sustainable than something else, I can judge it based on this definition. And that's why it's useful for me. So using this definition, and a graph that I likely stole off the internet, just because it looked really nice with the colors, I have to think to myself, you know, I'm not an environmentalist, I'm an ecologist. I mean, I love the natural world, but I'm not an environmentalist, I'm not an activist. But I do consider that all of us need to be environmentally robust in the way we do our activities, right? I recycle, I have a hybrid car, probably don't do a lot of things a lot of other people do, but I think I consider myself leading an environmentally robust life. I try to lead an environmentally robust life. That doesn't make me sustainable. Doesn't make my actions sustainable. A lot of people do things that are socially, very important. Activism as it regards to sustainability or environmentalism. And that's one aspect that they lead. And other people are talking about economic sustainability, right? The ability to continue to make a living, to continue to lead your life the way you want to lead your life as being sustainable. For me, activities to be truly sustainable, they have to be at the nexus of all three. I guarantee you that you and I can make a ton of money farming sea otters. $3,000 a pelt, I can find you a market any day of the year. So economically, absolutely sustainable. Absolutely, we'll make a ton of money. Environmentally, pretty darn robust. We'll farm right here in the kelp forest. We will maintain the kelp forest structure. We'll keep urchins at a minimum. In fact, we might actually enhance productivity in the region by farming the otters there. So again, environmentally, very robust. Socially, unacceptable. Right? So for me, I don't spend a lot of time investigating activities that only meet one or two of these. It might be the most socially responsible thing, but if you cannot make money on it, no one's going to continue doing it, right? If it is socially desirable, but harms the environment in any way, maybe we might not know yet, again, not worth doing. So that's kind of, for me, how I've been able to move into this realm of almost applied science. Not really social science, but for me it's not basic science, right? I'm starting to have to make some judgment calls here. So why am I talking to you guys? Well, I think that my understanding of how we take carbon and nitrogen naturally and package it into a sustainable network can help us to understand possibly how we can do some of our own activities. So that's kind of the idea here. All right, so why do we care? What's going wrong with the oceans? Well, the same thing that's going wrong with the planet. This curve, you've probably seen a bunch of other ones like it doesn't really matter. It's exponential. We're growing like crazy. Tons of reasons why, tons of different places on the planet, and a ton of solutions, not any of which we're all in agreement about, but the reality is it's happening, right? We also know that most of this is happening near the coast, anywhere on the planet, and that's even in California, right? So now we're putting pressure on the oceans, number one. So, let's just go to our definition. Are we meeting the needs of the present? No. Right, here's the capture fish. This is my own old graph. I redrew it. It looks really nice and it plays with my cartoons really well. But just extend that out to 2015, looks the exact same. This is capture fishing. This is true fisheries. We go out, we take what nature has created, we bring it back for ourselves. It's saturated. Right? We've known this for a while. It's been almost 20 years now that we're not getting any more. We're still getting fish. But we're not getting any more each year. We basically exploited the entire planet for seafood, natural seafood. This is a graph of various places around the planet and whether they're underexploited, fully exploited, overexploited, depleted, recovery. The reality is there's very little part of this planet that we have not touched and is probably not doing as well had we not touched it. Okay? So we are clearly not meeting the needs of the present this way. The other problem we have here is this is the amount, and I forget what it is, it's US millions of dollars, there you go, of seafood consumed in North America. That's this big looping circle. Those other areas are the amount of seafood we consume that's created from other regions. You obviously see the imbalance. So not only are we not meeting our own needs here in the United States, we have to import enough just to keep up with it. All right? Yeah. Probably not the best definition of sustainability. We can't meet the needs of the present. All right, what are we doing in the future? I mean, come on, this is an hour talk. Just go ask Steve Columbia, the director of Hopkins Marine Station. He'll tell you what's wrong with the ocean, right? And this one slide could be an hour's worth of just all of the problems. Our practices, the way they're currently going, and I have lots of good friends that are fishermen, and lots of good friends who are doing whatever they can to fish and make their living. But the reality is that across the planet, we're just not doing that great of a job of meeting the needs of the future because we are degrading so many of our systems to the level in which they're not producing at the rates they used to be producing. Now, climate's a big part of it, right? All the sardine issues that happen in Monterey Bay, I'm a biologist and I still don't really know. Is it due to El Nino? Is it due to long-term climate change? Is it due to us? We can argue about it, but the reality is, across the board, we're probably not doing that great of a job. Especially when we kill the sharks just for their fins. We dump all the shrimp over the side that aren't the shrimp we actually want, right? They say, what, 14 pounds of bycatch for 1 pound of shrimp you catch. You trawl in these really wonderful foundation species habitats. You take the foundation species out to get the one little consumable item you want, and the habitat's left for tens to hundreds of years of doing nothing. So again, we're not doing that good of a job in meeting the needs of the future. So we're not doing very well now. We're kind of screwing ourselves for the future. Here's just an example, and I love abalone. I grew up on abalone. My dad is probably part of the problem, but it was just such a cultural thing for us as a kid. This is China camp. This is Hopkins Spring Station, right? When there used to be an old Chinese camp on the one side, and on the other side was an abalone harvesting. Those abalone are this big. We now know that they're 15 to 25 years old to get this big, right? Look how big those are. Turns out there's no, well, first of all, this is just to show you we over-harvested them. This is the commercial harvest way after that was happening. This is 1800s, 1800s, early 1900s. Here's the commercial harvest of abalone, up, down during World War II, right? But back up again to sustainable, and then systematic crash until we outlawed commercial harvesting of abalone in 1995. Horrible story about how we just screwed up a wonderful organism. And we continue to do it. This is just a recent haul of poaching, right? So the funny part is, the only reason this picture happened is because we'd already killed the darn otters. So we killed the otters. Their prey, their number one prey item, had no predator for probably about 70 years. They got to gigantic sizes, so then we killed them. I mean, it's just, sometimes it just boggles you how messed up we can get. And now we have people say, gosh, you guys outlawed, not you guys, not me, but the state outlawed abalone fishing. I can't wait till we get back to the time we had those big ones. We had those big ones because our ancestors killed all the otters. I mean, sometimes it gets you. So, right now I would just like us all to agree that there's some sustainability issues we have. Not everything's bad, but there are some sustainability issues. So how do we move forward? Right, some recommendations. Let's develop some more sustainable practices. Easy. Not what I do, and I still fish hook and line, and I still use anchovies to catch barracuda, and probably things that other people don't do, but I do them because culturally I still like to do that. Marine protected areas. Let's close off some areas. I was part of that. A lot of other people are religiously part of it. Close them off. Don't let people fish. I've got an abalone farmer I work with that needs to harvest some kelp. They're a very sustainable program, but they can't harvest a marine protector. So doesn't always work for everyone. Restore marine habitats. Great idea. Great idea. Let's clean up our water quality first, because you can restore it all you want, but if you keep the pollution pouring into the water, don't bother restoring the river. Still issues, but one of my best friends, that's what he does. He restores salt marshes, right? And he needs to keep doing it. Develop alternative food. I'm not going to develop one. I like bacon. Sorry. I like tuna. I like certain things. I'm not the person probably to develop alternative food. I hate kale. But I eat seaweed and a ton of tofu. But we all have our personal things, right? Some of us will develop alternate food sources, and that's great for all of us. But again, it's not the solution to all of us. Profitable green fisheries. Figure out a way to use the bycatch, right? In a way that we have people out there right now that are making fake shrimp out of things that aren't even shrimp. It's basically plant products. You guys know K-Rab. K-Rab is fake crab that's created by pollock, which is a more easily and sustainably fished fish. Right? So there's ways to develop green fisheries. And the other way to do this is to farm it. Right? How many of you eat wild cow? Wild chicken? Wild pig? You don't want the wild pig, right? Every once in a while, a friend of yours comes home with a deer. Maybe they went out and got a deer or something. But for the most part, almost everything you eat is farmed or ranch. Hardly anything you eat from the ocean, until recently, has been farmed or ranch. So I'm not saying any one of these are important. I'm saying they're all important. I'm not saying any one is the way to go, and I just want to talk to you about the bottom one. Okay? So, is aquaculture even sustainable? 15 years ago, the aquarium didn't think so, and they shouldn't have thought so. Seafood Watch at the aquarium was very troubled by aquaculture practices around the planet, and because of Seafood Watch, aquacultural practices got themselves cleaned up in a lot of cases. Not all cases, but a lot. So you can't just say, just because you're farming the ocean, that you're inherently sustainable. But Aquaculture now makes up, this was 1/3 2005, it's 51% now. So it's actually over half. So we are not decreasing our capacity to eat seafood. We're increasing it almost linearly, and that has come from an exponential increase in the importance and contribution of aquaculture. All right? So, is it sustainable? We still need to figure that all out, but it's definitely exploding, and we are definitely utilizing it. And some of you probably don't even know you're eating farmed organisms because it's not required by law to tell you yet. Okay? Problems. I'm not an aquaculturist, right? I'm an underwater kelp forest guy. Right? I got drug into this by a couple of friends, and I had to figure out a way to keep my sanity. And there's issues, right? Aquaculture pollutes. You guys have probably heard these stories. You go down to Chile, you catch a ton of little bait fish to make up a meal to feed salmon. Salmon don't eat bait fish. Salmon live in streams in the ocean. They don't eat Chilean anchoveta, king salmon from Alaska. They don't co-occur, right? It's like feeding soy to polar bears. But you do that because you grow faster salmon, better salmon. That stuff pollutes the environment. It falls right through the cages. You know, the feedstock, like I was saying, so now they're trying to make vegetarian salmon. Salmon that eat soy. Salmon don't eat soy either. Salmon eat insects and plants that live in streams, and then when they get to the ocean, they eat zooplankton. Right? Well, those are hard things for us to accumulate and feed these guys. So, we're not doing a good job, we're not giving us nutrition. They start dying, we drug them. They don't look pink anymore because they're not getting that red shellfish that they usually eat, that little crayfish, so then we dye them. Right? Because you cannot have pink salmon not be pink. And I'll tell you a story a little later about red abalone being red. We genetically modify them because we can't get the same sex going on that they do on their own, right? They all get to choose their mommies and their daddies in the same streams or different streams. We get to choose a few, and then we mate them like crazy. So that definitely genetically restricts these organisms, and if they get out and mate with natural stocks, not so good. We all got to stop and think about ourselves here and how we do our own little modification of our genetics and you know, feel how hypocritical we're being potentially, but it's an issue. Habitat destruction, absolutely. Gigantic salmon farms sitting in a gorgeous, pristine fjord, habitat destruction. It's also the only way in those areas you can get farmed salmon. Disease. You've now taken all these animals that are free roaming, they've got critters to pick bugs off of them, they're eating a variety of foods, you've now penned them in, you fed them salmon chow, you've drugged them like crazy, they're going to get disease. Right? And then you deal with that, and you deal with that with more drugs, or you deal with that with other issues, or you deal with that by saying, okay, no more farmed salmon from Chile. So now you've just taken out an entire country's worth of commercial value. Invasive species, right? There's 5 species of seaweed that I studied that I didn't even know were invasive when I first started studying. They came over with the oysters in the 1920s. Why? Because we ate all of our native oysters, and they were training them over from the East Coast, and we ate all those. So now, all of us in California eat Pacific oysters that came from Asia. Even though they're growing in Washington, Oregon, and California, they came from Asia. Right? These are all issues. This is where for you to say, why would we ever think of aquaculture with all these issues? Okay? The reason is because of that curve. Right? Here's actually the modern curve. This is 2010. Look at that. That's why you're looking at aquaculture. Because people need to eat. And apparently we're not doing very well with birth control globally. So we've got some issues, right? And aquaculture is the solution. So despite that list of things I told you that are problematic, we've got to deal with it. And we're not going to deal with them all. So it's really hard to just make a law. No farms, you can't do that. Right? It's not a way to help us all deal with this. So what we want to do, my personal philosophy is, we want to nibble at those things by adding sustainability everywhere we possibly can. We need as many people thinking about it as possible, all aspects of the issues. The carbon footprint, the nitrogen footprint, the disease aspects, try to bring it as natural as possible, and I think then we'll get an understanding. So, that's just my 5-year perspective, because I haven't been in this very long, right? But a lot of that's also my common sense and my kind of social citizen perspective. So now I've kind of given you my introduction to aquaculture. Why do we even need a center for aquaculture? We'll talk about this a little later. One of the reasons is obviously this expansion. But what you didn't know is, of all that seafood that's created, the United States is the number 2 consumer of seafood on the planet. The number 14th producer of aquaculture. Right? So what that means is that we have the capacity to farm and terms of our coastline and our cerebral capacity, in terms of our academic institutions and our industry, we definitely have the ability to do this, but we are not. So it's almost like passing the buck. We keep saying this, you guys got to do a better job doing aquaculture, but we're going to go ahead and continue to buy it from everyone else because we're not producing it ourselves. So it's, again, another one of those problems. Why? We don't have the academic infrastructure in aquaculture itself. You go to Chile, the universities are there with the industry. They're there with the politicians at every town dealing with this. It's the same in Norway, the same in China, the same way in Canada. So for us, and you know, look, most of it is coming off the west coast, but that's almost all oysters. All right. So for us, I'll tell you a little bit about the story about my aquaculture background in terms of research. But last year we actually got a facility paid for. So Moss Line Marine Labs, I'm going to give you a 2-minute story of Moss Line Marine Labs, if you haven't already heard it. 1966, we bought a private laboratory in Moss Landing. It was called the Valdez Foundation. 7 institutions in the Cal State University: CSUMB, CSUMB, San Jose, San Francisco, Stanislaus, Sacramento, East Bay, which used to be Hayward, Fresno, all decided this is going to be our marine lab, we're going to share it. That's the Moss Line Marine Laboratories. Only do master's degrees only, and we've got, I think, 600 masters now since that time we've gotten through. All right, so that's our institution. 89 earthquake, right around now, World Series took down the Moss Line Marine Labs entirely. We were on the sand dune, we were gone. 1989 to 1999, we had to fight to get our new laboratory built. So in 1999, our new lab got built right next to the cemetery in Moss Landing. It's a gorgeous building, one of the 10 most environmentally friendly academic buildings in the nation. It's LEED Platinum. It's beautiful. It sits on a Native American midden site. There's no asphalt. Just in case someone happened to die on site, their spirits can get out of there. We've got 3 endangered species propagated on site. All the vegetation's been restored. There's not a chemical used in any of the wood, apparently. I mean, it's just amazing. There's no air conditioning. It's all this, I mean, it's just a wonderful spot. That's who we are. We didn't restore during that process, we didn't do our shore facility. Packard Foundation came in and said, hey, look, you got $1 million left over. This is 10 years later. You got to do something with it. So we decided to redo our shore facility. This is where our seawater gets pumped in. It's right next to the giant green monster we all call Mbari, right? So if you go down there and you see that big green building funded by the Packard Foundation, all the deep sea videos you see on Discovery Channel all comes out of there. We're the little teeny facility right next to it that pumps all the water from the ocean, from the canyon up, that we use for research. So let's use that Packard money to build this new facility. So we built the aquaculture facility because we thought, hey, maybe we can get some people interested in aquaculture and get it going for us. CSU does really well with a couple things. We don't make doctors, we don't make lawyers, kind of make politicians. We make nurses, we make forestry, we make MBAs like crazy. We think we can actually make aquaculture entrepreneurs. It's a great kind of middle ground where you don't have to have an enormous amount of education, but you got to be far enough along in terms of entrepreneurship, social sciences, economics. So we thought, maybe we can do something with this. So let's build this facility. Well then, people got interested, and we held a workshop in January to create not just a facility, a center for aquaculture at Moss Landing, but to create it for the entire CSU, housed at Moss Landing. So our facility becomes the house for a full network of all 23 campuses, 460,000 students, 48,000 faculty and staff, 23 research facilities, tons of federal and state money flowing in here, all these little labs that aren't networked. So the idea is, let's network them. Let's create that infrastructure for research, education, policy, and mostly entrepreneurship, right? Where's a startup going to come out on aquaculture? They're not, right? I don't know, how do any of you homebrew? Right, or there's at least one. Any of you make your own biodiesel? Right, your own compost? Right, you can sell that on the back end. Anyone have a cottage permit to sell at a farmer's market? Right? These are things you can do already on your own. There's people thinking they can do, you know what hydroponics is? Right, you already know. You can be growing tilapia in your backyard, get your cottage sales permit, sell it down here at the farmer's market if you can get through the certified aspects, which, trust me, I had to do. It takes a lot of work. But you guys can be doing this. You don't have to be a huge aquaculture firm. You can be doing it out of Humboldt and Chico. That's kind of our idea. That's what the state of California needs as an infrastructure. And that's what we're building. I'm not going to give you much more details on that because it's going a little crazy right now and my days are a little frenetic trying to handle it all. And we do want to interact with MIS. We do want to interact with Hopkins Marine Station. We are working with the business department at CSUMB. This is an inclusive event. This is not an exclusive one. We're just feel that we've got the lattice probably, to make that network. So that's the center. Okay. So is there really a potential for this? I just told you we're 14th, right? Why would you build a center in a country that's 14th, yet it's second in terms of consumption? Okay, well, let me just tell you a little bit about how we can do these things. I'm a seaweed guy. Let's talk about sustainable seaweed aquaculture. Is there even a potential to do this? This is where your seaweed. All right, raise hands. You heard the word nori? There we go, right? Sushi wrap paper, that's a red seaweed. Kombu, right? Real thick. Used to make dashi, wakame, seaweed salad. Throw it in your miso soup. It's a little green. Those are all great. They're all aquaculture. None of those are wild harvested. It's probably the #2 aquaculture product on the planet in terms of the amount harvested. They come from Chile, China, Canada, Japan. Very mechanized, very industrial. A lot of the infrastructure went to Japan came in the reconstruction after World War II. Right? The U.S. came in and tried to build in some infrastructure to provide jobs, one of which was seaweed harvesting or farming. So for the last 50, 60 years, most of our seaweed that we're used to eating comes from farms. Look at those things. As far as the eye can see in China, in that bay there, seaweed farms. Go look out your window. That's your view, right? And if you're lucky enough, that's your view and your kid's view and your mom's view and your uncle's view. That is not compatible with that. So there are reasons why aquaculture is not huge in California, right? And there's reasons why people move to California, right? Our environmental constraints on what we do here are very strict. Extreme. And there's other places that are stricter, but ours are very strict. So despite the fact we have an enormous coastline, we have an enormous amount of marine biologists, and we have lots of mouths that like to eat seafood, socially, we don't want to go here, right? We want it to fit within our curriculum. So we are not going to see giant salmon farms in the Monterey Bay National Marine Sanctuary. It is not going to happen. Might happen in the Gulf of Maine, might happen in the Gulf of Mexico, but it's not going to happen in Monterey Bay, right? Plus, if you put out here, just wait for the first winter storm. It's going to end up on the beach anyways. And there's certain reasons why you don't do things, and why you don't build in a floodplain or a water channel. So, how do you do this then? How do you take our insatiable need for seafood and our desire to do it locally, farms, local families, in a sustainable way, and fit it within this picture? We got to do it differently. And this is what I'd like to sell you on, is just the idea of developing a center to think about how to do this. These guys didn't come out of our center, but we're using them and our partnership with them research-wise as an example of possibly a model for how to do this in the future. This is Monterey Abalone Company, one of 4 abalone farms in the United States. Remember I told you you can't harvest abalone anymore? It's untrue. You can actually take your own abalone if you want, north of San Francisco. No scuba. You get to take 2. You can have 4 in your possession at any time. So you're free diving, right? And you cannot sell them. So everyone's like, oh gosh, that's still a lot of people taking abalone. Yeah, it turns out the white sharks are excellent policy control. Right? Just come in. There's no way you're going to spend too much time out there with the white sharks. And so people get their abalone. They're really stoked they got their abs. They go home and they're happy about it. It's very sustainable. Any abalone you eat in a restaurant in the state of California is farmed or imported. Nothing California wild. So these 4 farms make up the entire local component. They all sell red abalone, right? These guys, so the 3 farms, in fact, the reason I was rushing to get here is I was down in one in Cayucas, which is a land-based one. These guys here in Monterey are at the end of Wharf 2. So you walk out your door, you go down the wharf, you pass London Bridge. London Bridge? Yeah, London Bridge, you keep going, past Lulu's and right, past Sandbar, all the way at the end, this is Wharf 2. Okay, Robbie's Fish is on that side, Monterey Fish on that, there's a door. It looks just like this when it's open. When it's closed, you can't see anything. It says Monterey Abalone Company. And as you go in there, you walk down the stairs onto this floating farm sitting underneath the wharf. It's owned by Trevor on the bottom and Art on the top. These guys are awesome. They were on Dirty Jobs like 3 or 4 years ago. Dave Rolo was, if you guys know that show, he's out there with his cameraman puking on the side of the boat as they're harvesting Kelvin wine. It was hilarious. Trevor's dad was a biological collector, like Doc Ricketts, right? Collect organisms, send them off to universities to do research. That's what he's done. He met up with Art, who was a shrimp farmer in Ecuador and runs a vineyard up north, and they decided to do this about, I think it was about 18 years ago, right? White tablecloth clientele. Don't even ask how much the abalone costs. If you got the money to pay for it, you're lucky enough to eat it. It's great. but it's that kind of a item. And it's Seafood Watch Best Choice, right? Not only is it green, it is at the top of the green list. That's because it starts with A. But it is at the top of the green list. Only one species can be at the top of the green list, and farmed abalone is there, right? These guys are sustainable already. We love them. They hand harvest kelp. Kelp is the fastest growing seaweed on the planet. It's actually the fastest growing plant. Everyone says, oh, bamboo, it's baloney. It grows a foot a day. Bad conditions, it grows a foot a day. Good conditions, it grows 2 feet a day. That means you and I can go down there on a dive today. We can put a little cable tie, right? You know what cable ties are. On the bottom of the plant, come back tomorrow, and it just went to there. That means if you cut the top, the regulation of the state of California is you cut the upper 3 feet, you cut the top off, by tomorrow, it's already filled it in. Okay? So that's a very sustainable way of feeding a native species to the species that normally eats it. We're not bringing in Peruvian anchovetas to feed salmon. We're just taking the kelp and we're moving it over to the cages. Right? These are stocked full of red abalone, native again, from this habitat, this exact same habitat. You stuff these cages full of kelp, you put the cages back in the water, you just let them eat. These are cows. They just sit there and they chow on it. Anything that falls through falls into the water, with all the rest of the drift kelp that's floating around. Those issues of pollution, not as much of a big deal. Feeding, not as much of a big deal. Environmental issues with the harvesting of the kelp, not a big deal. These guys don't require fertilizers. They don't require drugs. You wouldn't be able to do drugs anyways because they would just go into water. You don't die, and you're feeding them what they normally eat. You're just kind of caging them up a bit. Right? They environmentally monitor, they have very minimal impact at the farm. You can't, when they go out and they do surveys, you can't notice the farm is even there. So, are there issues? Yeah, there's issues. Feed a red abalone all kelp. Look at that abalone on the left. Not red. Try selling that at a live market. You say, hey, look at the red abalone. They're going to say, which one's the red one? Right? This is what they look like on an all kelp diet. All kelp sustainable. Tastes pretty good. Takes 2 to 3 years to get to a market size. Not that size we saw in that photo. That size. Most people don't even want this abalone because, gosh, that's not what mom used to make me. Mom at least made me ones like this. Okay, that's 14 years to do that in a farm. Probably 18 years to do that in a while. So it takes a really long time to grow this. You have to harvest that kelp every week because they're little cows. They eat a lot. Not very good when all of a sudden there's El Nino, when there's big storms, when we just put in a whole bunch of really important MPAs between them and their kelp. They now have to get outside of those MPAs, even farther out to the more exposed sites to harvest their kelp. These are all issues. They're trying to make a living. They're not trying to rape and pillage, right? They're trying to help us solve a problem here. And we are doing a good job of keeping our environment robust, but it makes it hard. So, they came to me, this is how I got drug into it by these guys 10 years ago. They were the seaweed guy on the peninsula and said, look, we'd really like to farm some seaweed. 1, we don't have to go very far for it. 2, it seems a little bit more sustainable. We don't have to harvest anything. And 3, we'd like to diversify the diet because we just don't think the abs are getting everything they normally get when they're out in the field. Remember, I did that big food web for you. The abalone had like 8 lines pointing to them of all the different things they eat, not just kelp. So I came and said, you're right. Let's go ahead. Let's look at some red seaweeds. My expertise is in kelp, but I know red seaweeds as well. And we got funding from NOAA Sea Grant to do it was a 3-year study for a species called Grassellariopsis andersoni. Looks like long spaghetti. It's bright red. So we're over here. Well, on this picture, we're over here. Come to the wharf. This is the abalone farm. Those buoys here, none of you can see them, but I can see them. That's our seaweed farm that we made right there inside the wharf. We hung the species up like clotheslines. You basically cut it in little 10 centimeter chunks. You take polypro, right, twisted polypro line. You untwist it, it opens up, you stick the seaweed in there, you let it go, it snaps back onto it, you hang it up. This is what happens when you hang it up on these, so here's those lines. You hang it up. Right at the same spot we collected the seaweed from in the first. We're not bringing it in from other places. We're taking the native seaweed, we're hanging it in a more controlled fashion so that we can control its growth and we can easily harvest it. We then did a feeding experiment to see if the abalone would eat it. So, just by doing this little study, we found that it basically doubled every 7 to 10 days. I could take 100 pounds, hang it up on my clotheslines, and in 7 to 10 days I have 200 pounds. I would take 100 for the farm, and take 100 and put it right back out. It's like rice, right? You guys know how rice works, right? See people, they go out, they'll take 10 handfuls, 1 goes back in, 9 stays for us. It's the same thing for us. Very sustainable, very little impact, and you don't even have to go. Once you take your first sample, you don't have to go back anymore, because you just use your proceeds each time to refarm. So, got into this diet, right? It's great, 40,000. I said, do everything the way you normally do it. Stock the tanks, feed them the rest. Let's just add a little seaweed, red seaweed on top of what you do. 2.5%, 5%, 7.5%. So after a year's worth, mortality rates were the same. There was no, they weren't dying because we had a red seaweed. They were snottier, which you want to be when you're a snail, right? Increased health. We had an issue with hypoxia where oxygen was really low. The ones that were fed the diet of red algae survived a little bit better during that issue. We had a 25% increase in growth by adding 5% red algae on top. This is algae they normally would have eaten, right, in the field. 25% increase in growth. That means 25% less time to get to market on that's 9 months of labor that just got cut. That's cost. This is a green, sustainable product, very high end, just got cheaper by making it more sustainable. Increased shell pigmentation with only 2.5. Look at those guys. Can you tell when I start feeding red algae? Look at that line. That's when they got it. Fortunately for them, they named them super abs. You don't want to Google it. You're not going to get a red apple. So now they call them super reds. But the reality is they grow faster, they look better, they feel better, they're healthier, they have different, and they're less expensive to create. Still not enough though. We don't know if the clientele are getting it, so we took all of our abalone, the kelp ones, and the kelp plus red algae ones. We went up to Pacific Edge Restaurant. If you get a chance to go there, it's awesome out in Carmel Islands. Mark Ayers there was a sustainable chef. We took the super reds and the regular red abalone, and we did side-by-side 4 different dishes. Look at these dishes. Abalone ceviche, steak and eggs, which was basically an abalone steak with quail eggs. Seared abalone, side-by-side, Sunset Magazine, Food and Wine, San Francisco Chronicle, they're all there. 80% of them liked it. Better with red. They couldn't tell what it was. Only the chef knew. And they said it was the flavor they remembered when they were kids. It was more like the flavor they remembered. And they had no different. We didn't even tell them what was different about them that they were fed different. They just 80% liked it better. So now we've taken the greenest, probably, farmed organism we have in California, and we made it greener and cheaper. That's what I mean about just adding sustainability at different levels. All right, so I ask my students all the time, Honda Civic, Civic Hybrid, right? Which one do you have? You get the Civic. Why? Because it's cheaper. What if the hybrid was less expensive? It's a no-brainer. We would all be driving hybrids. One, it's better for us financially, right, to maintain it with the less gas. And it's better for the environment. And we all look better about it because we're doing something. I mean, there's the social part of it. But it's not true. This was a case where it's true. So for us in this center, the idea is how do you profit on sustainability? It has to be profitable. We cannot rely only on subsidies. Oh, here's $20,000, go do something cool, let's prove it works. No, you have to do something that is sustainable economically. Okay. So here, if you guys remember, I had this little picture of what the key was, and I didn't know what the link was. The link is money. The link is when you demonstrate the profitability of it, right? It's going to go. You don't have to do anything else. People will figure it out. All the abalone farms now feed red algae to their abalone. Now that's the baseline. The other one's gone. You will not find any. Go try to find. Well, sorry, not true. Go to a couple restaurants in California, find the abalone, ask for the shells. If they're dull, pretty much guarantee you they're not from California. Probably some other farm, Japan, China, Australia, New Zealand, South Africa, that don't feed them red algae. All the ones in California do. For these exact reasons. Why would you not? Right? So we haven't revolutionized the industry, but we've made it better. All right? Okay, so now I get it. I try not to pat myself on the back, but now I get to, because this is my company. So here I am, father of 7, soccer dad, already got a chaotic enough life. Turns out I married a chef. If you guys ever go to Monterey Fish House, she used to manage down there in Cooler Ranch and Marina. If anyone's from Marina, she used to also manage there. And you know, I'm sitting there doing these abalone studies, and I'm bringing stuff back, and she's like, you know, those actually taste good. Because the abs don't care. I wasn't even thinking about it. She goes, and they look good, and you know, we should think about maybe there's a way to do farmed seaweed in California for, you know, high-end restaurants. And right around that time, we had formed this LLC called Sustainable Sea Culture Technologies with my buddy, if you know Ross Clark. Ross Clark's at Moss Lane Marine Labs. He's the climate czar for the city of Santa Cruz. He used to be on the Coastal Commission, and he works with the wetlands group at CHMB in Monterey. But he works with farmers on how to clean up the water. So the first part of our company was big seaweed tanks to biofilter the really nastiness, the E. coli tainted spinach, the massive amount of pesticides going on to our RD, all that stuff that happens in the Salinas Valley, which we know we all eat. It's the salad bowl of the planet, right? We already know it's $8 billion comes out of Salinas Valley. A lot of stuff flows right. In fact, I always joke, and you're all old enough. Moss Lane is kind of the sphincter of the valley. All that stuff flows right past us, right? It is gnarly how nasty Elkhorn Slough and the Salinas River are. It really is bad. So his job is to clean it up. He makes artificial wetlands on farmland. You might see him as you drive by. This wetland created by CCWG and PG&E, that's Ross Clark. And the idea is to have these gigantic tanks sitting on the farms taking their nasty water, which is mostly nitrogen. I say nasty, it's not a super fun site, but it's a lot of nitrogen. And in fact, if you go to Home Depot, you get an orange bucket, you fill it with Home Depot fertilizer, add water to it, let it steep into a tea for 24 hours, take all that fertilizer out, that's the nitrogen content of Elkhorn Slough right now, or the Salinas River. So we gotta get it out, right? Seaweed takes it out. Our idea is, as part of this company, have these giant tanks, water goes through, seaweed takes out the nitrogen, cleaner water goes into the river. Now you have a seaweed product. Start thinking about all the things you do with it. Bioethanol, number one on the list. Human protein, you can extract it out of there. Gotta deal with all the gnarliness, right? But you can throw it right back in the fields as a fertilizer. It turns out a lot of the nitrogen in that seaweed is locked up as liquid-free fertilizer. Free liquid fertilizer, throw it back in as a mulch. It's got some salt, so you can't just throw it directly. Hey, and it's coming with its own pesticides that it took out of your water. So you're basically, the farmers are recycling their own nitrogen, and they like it. Because if you think about those salmon farmers in Washington who were put out of jobs, and they said, go in and start taking these dams out for us, right? Spotted owl. If any of you remember, you guys are half of you are way too young to know this stuff. But the idea was they're putting fishermen to work taking out dams, and they hated it, right? They knew they were doing a social good, but it's not what they do. We're fishermen. These are farmers. They like the fact that even though it's seaweed, they're farming, right? These are good. So that's that part. I'm not going to talk about Ross anymore. He's a great guy, and you should have to come talk. He's awesome, but I'm going to let him talk about it. So then the flip side of that was, and I'm involved in all that, the flip side was Erica, my wife, and I said, okay, let's let Ross do that, and we'll keep working on it, but we really think we can do a truly sustainable farm. So it's now called Monterey Bay Seaweeds. We were in the Coast Weekly a couple months ago for the love of seaweed. It was a big article about us in there and all of our kids. And what do? We sustainably, based on my definition, produce raw, fresh, and alive seaweed for premium markets. We don't do nori, we don't do kombu, we don't do wakame, because I don't want those big old farms sitting off of our coast. And I consult for companies to do that, and I used to do that in Chile. We can't do it in California. So we focus on species you can't do. Species that chefs love, but they can't get. They're either too rare and they can't harvest them because they'll over-harvest them. They're in nasty areas. Our ogo naturally is found in mud. Most chefs don't like to go down in the mud and dig it out. And our sea lettuce we grow is too ephemeral. You go out today, you see all the lettuce, you go, okay, I'm going to come back with my sous chef and go get some, and it's gone because it's just hit or miss. So we thought, you know what? Let's do it this way. We're the only Fish and Wildlife registered seaweed farm in California. The only one. Also the only one found, run by a marine biologist. Also the only one on state property in a marine lab. Okay, so what's our mission? Part of it, and I think the most important, is just to demonstrate the utility of this. I'm not out to make a ton of money. I've already got way too many jobs. I'm also the editor of the top seaweed journal on the planet, Journal of Phycology, which takes way too much more of my time. I don't want to have another business. My family likes it. We are a family farm. It's just me, my wife, and the kids, and one grad student. That's our entire farm. But the idea is just to demonstrate you can do this. This is the mom and pop aspect. This is how the vineyard started in California. In the 80s, we had a couple of big ones, and then a lot of people took their retirement money, went to UC Davis, took a couple of classes, and then boom, man, the entire 46 highway going from Paso Robles to Cayucas is full of mom and pop vineyards. And they invested, now they're family. I mean, there's no reason we can't do this in aquaculture as well. Shrimp maybe, tilapia, sturgeon, abalone, oysters, things like that. We also want to increase the public awareness of the fact that seaweeds are good for you. Okay? No fat in any of them. None. The reds and the brown seaweeds have no digestible sugar. The seaweeds I make, no digestible sugar. Everything is fiber. So if you're diabetic, by all means bring it on. These are perfect for you. Protein, the same as kale. My dose is 1 gram of protein for every ounce, fresh ounce. It's the same as kale. But kale has sugar, And other aspects, seaweeds have iodine, iron, manganese. The B12, for those of you who don't eat a lot of meat, you realize it's really hard to get B12 out of plants. 50% the recommended daily allowance from seaweed. And that's just the way they do it, right? So the idea is, hey, we can use our little company to make people aware that it's not just a garnish, right? And it's not just dry paper that you can buy at Costco that is now flavored with buffalo seasoning or ranch, right? My kids love it, and I eat it too. Come on, don't get me, I'm not putting that down. I go to Sapporo once a week and I eat their wakame salad. I'm not putting it down, but that's what other people do. We had to come to California to figure out what can we do. Well, we're doing something different that other people don't do. We are a local farm, very minor carbon footprint, I'll tell you about, and a new product. We encourage the creative use of fresh seaweed. Go down to Poke Lab right now, they got my seaweed. My logo's in the Dakine tuna. It's awesome. Does it completely different. Some of them blanch it, some of them, they're making kimchi out of it. One of our seaweeds, they make agar, if you know about agar, and they use it in desserts, right? The guy grills our sea lettuce, blends it up like a smoothie, plates it out, and freezes it to make these like chips that he sticks sugar water, well, whatever, simple syrup I think it is, but it hardens to make a seaweed rock candy that he crumbles on his homemade dessert. And it's just unbelievable that they're starting to think about it as something more than just something you throw on the side. We have 25 restaurants right now in Monterey Bay that we serve, including the salad bar at Monterey Bay Aquarium. 10,000 people come through there. Here's your salad. What's that right next to it? That's fresh, family-owned, farmed, local Monterey Bay seaweed, raw. It's in seawater. They pick it up, they throw it in the salad. He goes through probably 15 pounds a week with people who have no idea. They come to the aquarium one time in their life, and they eat the seaweed salad and they leave. It's just amazing how different it's become. We also want to demonstrate the idea of locally family-owned because I think it's going to be a really important aspect for California. So I get this talk, a similar talk to this, at Stanford in front of Google, trying to get them to use our seaweed in their cafes. And in there was Stanford, Cal, and USC. And my son in the picture with his USC Trojan shirt was hilarious. The Stanford and Cal were joking that we had our loyalties wrong. But the idea is there's universities now that are interested in us in terms of food service because the student clientele is becoming so conscious of health, environmental sustainability, and these new aspects. A lot of you guys, well, I'm going to say it for you, a lot of you guys like to cook. Totally different than I do grilled cheese. But a lot of you like to cook. My brother is an excellent self-trained home chef. He gets a bag whenever he comes by because he just likes to mess with it. And I think it's just a change in the culture that a lot of you guys have been part of. And we work with that. Heirloom tomatoes and going out and picking your own mushrooms. Hopefully, the ones that don't do bad things. So what do? We have land-based tank culture. We're not out in the water. We're only right now at the Marine Lab because we need the pipe and it's really hard to get a permit to get water. Right? So we're at the Marine Lab and we're part of an industrial partnership. We're there, the abalone company's there. So even though I'm a professor there, we actually have a spot for the company. We do tumble culture. Tumble culture, I'll just show you this. These are tanks. These are large pound tanks. Where do I buy them? Ag companies. They have for dirt cheap. They have a cone. I run a pipe down the middle. That is a giant beta fish air pump. Same one you guys all use and hanging out in your little dorm room. It's like this big, mine's that big. Pumps air through there to the bottom. Bubbles go up. When bubbles go up, water goes with it. When water goes with it, it hits the surface, goes to the sides, hits the walls, has to come back down, goes to the corner, makes a great convection cell just like your oven. Throw my seaweed in there, does the exact same thing. Goes to the bottom, goes to the top, probably about 50,000 times a day. Right? These are my smaller tanks here. That are the ones we use to sell. But the point is, this is raw seawater coming in these tanks from the ocean. No fertilizer, no chemicals, nothing. It's already coming in for the research lab anyways. Our carbon footprint is minimal. We're taking the stuff that would have gone back to the ocean anyways. We've got a tiny little amp pump and natural sunlight. Right? So the energy draw for this is extremely low. We don't have to harvest seed stock. Because once we put a handful in, a week later we got 2. So what I do is we grow about 100 pounds worth, we take 20 out, we sell it to restaurants, we leave the 100 pounds in, it continues to grow. When we get enough, we make a 3rd tank, a 4th tank, etc. We don't go back to the field and constantly harvest native stocks. We don't have to deal with seeds. We don't have to deal with hormones. We don't have to deal with chemicals. Monterey Bay, 2nd most productive ocean or bay on the planet outside of South Africa. It's all coming from deep water. It's not that nasty Elkhorn Slough water that floats on the top. We're down at 75 feet at the mouth of the canyon. Native California species only. Guaranteed you will not get this ecologist using non-native species in ours. Our Ogo is different than the Hawaiian Ogo. It's the California Ogo. Our dulse is different than the East Coast dulse. We do not import things just to grow them. Even though they're in tanks, still is just against our principles. We target species that cannot be sustainably harvested. Why? Because why worry about them? They're sustainably harvesting. I have no issues with nori, kombu, and wakame culture. There's no issues with them. They're pretty large farms, and we don't want to necessarily see them on our coast, but there's not much environmental degradation happening because of them. So please support those as well. We just stay away from that because other people do it well. There's some species of kelp here. Giant kelp in front of us. By all means, harvest it away because we already know it's very sustainable. That's not something we're going to focus on. And finally, we need not a single bit of fresh water is used here. None. Our freshwater footprint in the state of California is zero. Well, I have to go to the bathroom every once in a while, but other than that, that's it. Right? This is just an example of how you can do this in California. Okay? So, there we go. This is what it looks like. That's the bubbles coming up in the middle, the water coming in. These are these giant handfuls of dulse that are floating around. Okay, so kind of a good story. Obviously, I'm very enthusiastic about it because it's my company. And I was going to see, I don't know if it'll work. Oh, anyways, it's a link. MontereyBaySeaweeds.com if you want to look at the website. It's gorgeous. It's made for chefs and stuff, but just so you can kind of see it. We've done the nutritional values on it, but the reality is this is a premium seaweed. We deliver it raw and alive to the chefs. They can do whatever they want with it. It's not dry, it hasn't been processed. It's like going to your farmer's market and getting it fresh off the truck with the dirt still on it. This is in seawater. It lives for a week once we give it to them in the fridge. That's why we're able to conjure up a higher price. We can't compete with Asian-produced farmed kelp. We can't. We can't compete with this because they can't make this. They cannot make California tumble-cultured seaweed in China affordably enough to be able to compete with us here. So we're kind of barking on that whole local, family-owned, novel product as a way to come in. We're not. People ask us all the time, hey, if you have kelp, can you get us 100 tons for this? That's not us. There are other companies that do it. So we want to use this as an example of how to think about the environment with which you're in, the constraints that you have upon you, and ask yourself, what should aquaculture in California look like? Right? What type do we as Californians want? Right? And it's probably going to be these little abalone farms, these mom and pop mussel farms, maybe a mom and pop seaweed farm, maybe some aquaponics where we're growing some seaweed with tilapia or sturgeon. Maybe we're going to make fake caviar out of seaweed product here. Maybe in California we might do a lot of service-related aquaculture, right? Not just big, large farms, but maybe some of the more cerebral aspects of it. Farm design, maybe that might be that's what made Silicon Valley famous. They don't just make all the semiconductors, they make everything that goes with it. You come to Silicon Valley to develop new products because everything is there. Why can't we do the same thing in California, have it all here? We won't necessarily have large farms, but maybe we'll have people who are very good at designing large farms. We can market that out as well. So there's my last slide, is to bring you back to what's the global future of aquaculture in California play a part. Right now we're not playing a part. There's very little growth, a lot of it's restrictions based on permits, etc. But I think we really can, and I think a lot of that's going to be involving the large array of institutions we have here in California. I don't think any of you probably have got any expertise in aquaculture at all. I guarantee you, probably all of you will be helpful to a startup farm somewhere in just the way you think about the world and some of the other skills you have. We need poli-sci. I don't even know how to use QuickBooks, right? And my wife's in there dealing with the seaweed, and my high school kids trying to help me deal with QuickBooks. I don't even know what a price point is, right? I walk into the restaurants with my Teenage Mutant Ninja Turtle shirt on, these shorts and these flip-flops. I have no business being in the restaurant. They love seeing me because I just brighten up their day, I guess. But the reality is, that doesn't go well. We're making a business. These businesses need help. A lot of them have great ideas, but I think a lot of people in California don't recognize how useful the rest of industry is to aquaculture. Oh, we don't do that. I don't know how to do tanks. Really? You don't know how to cut PVC? Well, I just finished my plumbing at the house. It's the same thing, right? Half of you have been nodding to almost everything I've been saying as if it's apparently common sense enough. I haven't said anything to you that's rocket science. There's no formulas anywhere up there. Yet you're all nodding because it seems pretty logical, and that's where we are right now. So I think the future is, or will California play a part? I'm hoping it will. I'm hoping it will only when we start to think about the products we want to create, what our industry we'd like to look at. What's an industry we'd like to be proud of, but what's an industry we can grow? We don't want to have such a restriction that we can't do anything. I mean, it's just not going to help. I would like us to be above 14. I would like to be able to come out and say, wow, that's a California salmon. That'd be awesome. That would really be great. And it doesn't have as many issues as the Chilean one, right? I mean, I'd like to be able to be proud of California's role in feeding our own people, and the U.S. as well. So, it's kind of a bit of a soapbox. I don't really have much credentials to be on that soapbox, except for I'm a consumer and now a producer. And I got a little bit of credential in that I know what the seaweed does. But other than that, I just kind of want to give you that perspective. And I'm more than happy to answer anyone's questions. And by all means, you know, email. In fact, if you go to the website, you get my cell phone. Because I don't even know how to distance myself from my personal life. So by all means, call me on the phone and tell me you heard me talk and come up. Yeah?
I noted the land-based farming, particularly the tumble culture where you pump seawater from salt water from sea. I was wondering if that farming is also applicable on lakes with quality products just as same as coming from sea.
Absolutely. In fact, we stole it from the people who do microalgae. Super green milkshakes, those, I don't know, like Walla makes them, whatever. They look an interesting color of green. They usually have spirulina or other microalgae. These are done in lakes. They're done in these, they're like giant trash bag systems where they kind of cordon off part of the lake, and they do, by doing so, they can keep the algae they're growing separate, and they can do bubbles that separate it from the rest of the lake. They can add fertilizer. So it is done. Problem with microalgae, there's two problems you have with really small things. One, you gotta get them out, and water sticks to little things, so the dewatering process is really hard. The second is, they shade the bottom really quickly. They're little cells, but they get so thick, it's almost like a milkshake. And when you dewater, you realize there's really not that much there. So little pieces, it's like dust, right? A little bit of dust in a room, like in a photo room, can cause real big problems. Seaweed is more packaged, and so we're more, I can reach in and take a handful out. That would take me hours to get the same amount of microalgae. So we use similar technologies, but a lot of the process is really different because of the way that the organisms work. The other thing that's really important here to realize is these are seaweeds, right? When kids ask, what's a seaweed? It's an algae, a piece of algae that you can see, that lives in the sea. That's what a seaweed is, right? They're salty. It's totally different, right? They're not plants. Everyone thinks they're seaweed, but they're not plants. Red seaweeds, the dulse, evolved probably 400 million years prior to anything that emerged on land as a plant. These are not plants. So although they're photosynthetic, you kind of got to get out of this realm of, hey, they're just like cabbage. They're not, right? They're not geared towards an existence on land. So what you're talking about is what we call aquatic. Aquatic is anything that's in the water, whether it's freshwater or saltwater. And we do share, but there's a lot of real important differences. So most of the stuff going on in the lakes are actually done at the level of the entire lake, rather than doing the tumble culture itself.
So you obviously pump water from the ocean. What do you do or what will we be able to do when you don't have that opportunity to get direct seawater?
So business majors in here, well, do you guys have majors? I don't know. I don't know much about your school. You guys have majors, right? Business majors, or anyone? No one does business or has business classes? Okay. One of the big, you know about IP, right? Intellectual property. I don't have very much IP here because everything I've told you is in the scientific literature other people have done or it's common sense. So my IP comes with me not telling you what I do. Yeah, right? Trade secrets, right? And that's one thing the dodo like me who does science learn really quickly about business is just keep it quiet. But my point of it is we've been working on that for years. In fact, I can do it really quickly. Watch this. It's not really quick. I just scared the computer. I want my food web. It's there. I know it's there. There it is. There's something you're missing here. Here's the seaweed. Carbon and nitrogen has to come in, right? That means carbon and nitrogen is coming out. As the seaweed is growing in seawater, whether it be natural seawater or artificial, it's taking carbon out. You guys know what happens to water when you take carbon out? The pH goes up. Chemistry changes completely. We started doing this, growing it in these tanks. Basically, I ran my tank and I turned the water off. I said, hey, how long can we go without having to turn the water back on? The chemistry in the tank changed because of the darn seaweed itself. So we didn't get a good handle on how much carbon to put back in to balance it. It's really expensive to do the technology and nitrogen. But you can now imagine yourself being in a place where we have excess carbon dioxide and using that in Iowa to grow my seaweed to feed Spago in New York, right? Because probably, I imagine the energy costs in Iowa or the land costs to run a farm are far different than within 10 feet of Monterey Bay. Right, so we love big. So that's my short answer. It's not easy, and it's because of the darn seaweed itself.
On that point, I've been super itching this whole time ever since I heard aquaponics at the very beginning to ask, how have you been experimenting with, non-sea based, land-based aquaponics in the use of growing kelp and saltwater fish?
So one of the things that's going, remember our lab just built this facility up, and right now we're just trying to get the equipment in. The big thing for us, aquaponics is a freshwater perspective. Hydroponics, aquaponics. The idea is you grow a freshwater fish with lettuce, and the fish pisses in the water, and then the lettuce takes it up, and you got your lettuce in the back, and it cleans up the water, goes back to the tilapia. And so you got two products. That's what aquaponics is, and there's a very strict kind of rationale to all of that. We do it in seawater. It's called mariculture, or integrated mariculture. In fact, it's integrated multi-trophic aquaculture, IMTO. Anyways, so it's the same thing, but it's with salty stuff, right? The problem is people have been trying to use lettuce. So they're trying to grow saltwater, and it doesn't work, obviously, because lettuce doesn't. So we're just now getting to the point with us of having a sturgeon tank. We have sturgeon and sand dabs are the two we're looking at. And having it linked to where our dulse tank is sitting there. It's taking the water, instead of from the ocean, it's taking that in, it's taking the nutrients out, the water's going, just like I told you about the farm, right, where we take the farm runoff before it goes to the river, it goes back into the sturgeon tank. And so we're just starting to do that survey. So the sturgeon would basically be feeding their own food, or our food, and it's totally natural, it's just ammonium, it's not anything bad. And so that's one aspect of it. But an even more important aspect is to then link it up to oysters. So ocean acidification, you guys are probably, okay. Right, CO2 is going up, pH in the water is going down. Things that make calcium carbonate skeletons, corals, oysters, abalone, having a harder time dealing with it. All right, there's that graph again. Seaweed take up the carbon dioxide. They shift it the other way. I just told you that they take it up so much they raise the pH. But in fact, they could drop, if you drop the pH, they can buffer that. So not only are we looking at maybe doing fish with seaweed, but by adding oysters in there, we can potentially help the shellfish industry deal with ocean acidification by having them grow in conjunction with that, these biocleansing seaweed tanks. And I think that's when everything really gets exciting. It adds value to other farms that are already in existence. It'll drop the price of the seaweed in general. I don't want to drop it entirely. I like it being a premium product because it allows startups to have something, allows some value so they can start it. But I wouldn't mind it being lower because right now, I ship to LA, I ship to Spago. Right? I'd love to ship to a bunch of other restaurants. At this point, they just can't afford us. I don't want to be the abalone of the seaweed industry. But it's a great question, and that's where we go. And I think that's like a 20-year goal for us to start to do that. Yeah, there's a...
I think it's too out there to say that like maybe this could be used as remediation for natural areas of the sea, like coral reefs. Or is it just too local, the effect that it has as a buffer?
I don't think it's too far to say that at all. In fact, I think there's a lot of people who are looking at
So you could just put huge plantations around areas and protect them from acidification?
especially at the estuaries, put them at the mouths, or don't do that. Do a farm more like you would see in Japan or China. So 15 years ago, when I was not even doing aquaculture, I was just doing kelp. A guy called and wanted me to help him design this ridiculous size farm to grow in front of the Mississippi. Because he wanted to take so the dead zone in front of the Mississippi River is all the nitrogen flowing out, causing the plankton bloom. The plankton then die, degrade, suck all the oxygen out of the water, and you get the dead zone. He's like, if we could put a kelp farm right out in front of Louisiana and suck up all the nitrogen, maybe we could buy. So people are thinking about that, exactly what you're talking about. But that's just a close-up. That's not my tumble culture. That would be doing one of these other aspects. Just talk to some people about they want to put a kelp for us on a floating raft. right? They've talked about putting in front of Japan previously, where they would they would let the raft go, and it would go up the natural currents, and it would be taking nutrients out as it goes, and then they would harvest it at the top of the island, right? So people are starting to think exactly, and I think that's the cool part. What I think people have had an issue with is just thinking about seaweeds in general. Seaweeds are not part of the problem, as far as we can tell, except for the yachting that went on in the Beijing Olympics, and the seaweed balloon where they had to have the People's Army out there to get all the, you guys remember those images of all that? That's probably the only seaweed issue I've ever heard of. Other than that, seaweed take up nutrients, they provide habitat, they're providing food and energy. So I think the kind of stuff you're talking, now it becomes scale. Are you solving enough of a problem for the cost?
That's what I was gonna do with another question, ask you, like, can you scale up the sustainable production to large operations?
Yeah, so mine's modular. I mean, just think of it as a little canister filter and just start adding them on. The farm is a little different. The bigger you get, the deeper you go, the more you gotta engineer it. But I would imagine the answer is yes. And part of the point is, we're gonna have to pony up some money, right? Some of this has to be subsidized, at least to get them in. Once they're in, a lot of these could be self-sustaining. And you can have cooperatives come through and harvest them. There's people who want to create kelp forests, not for the kelp, but for the fishes that are going to be attracted. Because they're going to see that as new. It's not going to be the same stuff we're doing. It's a new habitat. It's new amounts of consumables that are being produced. I think that's where people start thinking. And that's where it gets weird, though. That's the legal aspects, the political aspects.
So this is more sort of question, or it's a little bit long. But so I was like nodding to everything that Rich was saying. Everyone in like this room, I think agrees with the future of aquaculture that you picture. One of the reasons why aquaculture has been so controversial is because we find the species that people demand, so salmon and tuna. So in the long term, like, how do you change consumer behavior so that they demand what can be sustainably harvested in California?
Great question. I'm not trained to answer it. I'm going to tell you how we answer
Yeah, I
it.
don't know if this.
No. So I walk into a restaurant, I open a bag of seaweed that I grew. The chef looks at it, and most of the chefs go, we don't use seaweed. Everyone says, well, why don't you go to a sushi restaurant? Sushi restaurants don't want my seaweed because they want nori, kombu, wakame done in a particular way. I've had the hardest time. I find the Poke Lab's the closest thing I have to a sushi restaurant, right? And it's not a sushi restaurant. I have steakhouses and country clubs. There's people flying in from all over the planet to go play golf here, and they're eating a burger with fried seaweed on it. Because I walked in to a chef who said, nah, don't bother, we're not gonna do anything. I opened the bag in front of him. I spoke with a little bit of authority about what the seaweed was, and I said, I made this, and this is how I made it. And he tasted it, or she tasted it, and they liked it, and then I talked about what happens when you fry it, and it tastes like bacon, and if you do this with this one, it does that, and if you drop this one in gin, it turns orange, and it's really cool. And they did it, and they liked it, and they liked the story. And that's a lot of effort to do, but that's probably how you do it more. I think this whole push, just so you guys know, I eat everything. I eat organic, I eat non-organic, I've eaten all over the planet and a bunch of places I probably shouldn't have eaten. But I realize that there's a big push right now for locally produced. There's a push for you guys knowing where the sources of your stuff come from. Like, well, look at you, you've got kale sitting right in front of you, right? I'm sure you know exactly where you bought that, and if you went and tracked them down, they'll tell you exactly when they cut it. You like that. You're doing that kind of, organic is a bad word, grassroots. You're doing that on your own, and at a local level, people are responding to it. You don't do that at Costco by saying, I don't want your farm salmon. Well, all we have is farm salmon. Okay, well, I'm not shopping. What are you talking about? You're still going to get your toilet paper at Costco. So don't say you're not shopping. You walked into the store. You obviously didn't walk in there for sustainable food because you went into Costco. So the idea is sometimes we shoot at a really, again,